Can you tell me what will be VAC? It's simple, not difficult. Can you tell me what will be VAC? This is A, this is C. Can we get from here VAC? Think about it. VAC, not difficult. Think about it. Think about it. You know, in this branch, what current did flow? Correct, yeah? On this, in this branch, suppose if I'm to ask VAC, how will you go about it? You will say input again at A, output at infinity. Correct, yeah?
Yes, sir.
Yes, sir.
Okay. That'll get you I by 4 in this branch. Correct?
Yeah. Yes.
And then when current comes over here, it will split it again in 4 equal parts, 3 equal parts, correct?
Yes, sir.
So I by 4 divided by 3 this way, I by 4 divided by 3 this way, and I by 4 divided by 3 this way, correct?
Yes, sir.
Yes,
So
sir.
how much will I get in this one? This
I
one
by-
I got I by 4, and then I by 4 divided by 3. In this one, how much will I get? I by 12, correct here?
Yes, sir.
This is when A is input and infinity is output, correct?
Yes,
Yes,
sir.
sir.
And then we will go by the same logic, which is infinity is input and C is output, correct?
Yes, sir.
So if C is output, then I by 4 here, I by 4 here, I by 4 here, and I by 4 here. That is fine. But if I by 4 over here, then what was in this one? Because I have to follow this path, correct? First was A input and infinity output. I got it divided in I by 4 and I by 12. Now we are saying that infinity is input and C is output. Infinity is input and C is output. Then I got over here I by 4. Here I by 4, I by 4, I by 4, correct? Now
Yes,
look
sir.
at this I by 4. I'm darkening it. Look at this I by 4. This is I by 4, correct? Yeah. Think about it. Is it I by 4 or not?
Yes,
Yes,
sir.
sir.
I by 4, but I got this I by 4 split in 3 parts, correct?
Yes, sir.
Yeah. Yes, sir.
This one will be I by 12, so will be this, and so this. Correct?
Yes, sir.
Yes, sir.
Now think of what will you be getting as potential difference when you move from here to here and here to here. When you move from here to here, you got one current as I by 4, the other current as I by 12, correct? So
Yes,
I
sir.
by 4 into R plus I by 12 into R. When you move through this. And when you move through this, again you got I by 4 here and I by 12 here. So this into 2. Where yeah? Take it out.
Sir, it's R equivalent is 2 by 3 R.
Okay, so that will get you R equivalent. Correct? Yeah, I get it because that's important over here. Nowadays they're asking this question. So not much. In one case I by 4, in the other case I by 12. Correct?
Yes, sir.
And then we will have to get VAC, whichever path you follow. VAC is gettable over here. Few questions I'll be uploading today on this methodology. Fine, yeah?
Yes,
Sir.
sir.
Sorry.
When we say that, like when we take VC minus V infinity,
Say.
I mean, like
Can
you
we
said,
say-
we'll get I by 4 coming from C
Yeah.
with the down arrow.
I by 4 coming to C from all the sides.
But then I by 12 is coming.
Yeah. I by, see, which one you want to go with? Input where?
We'll take on both, right? On A and C.
Which one do you want to go with? Input
On-
infinity? Okay. So input is at infinity and C is where I am siphoning current. Is it okay? So
Yes,
one thing we are sure of, that these branches, this will see I by 4, agreed? This will see I by 4, agreed. This will see I by 4, agreed. And this will see I by 4. Right here, right on it?
Yes, sir.
Now, I by 4 I got in this from which branches? This, and this, correct? Getting it or not? This, and this. They must have reconciled to get you I by 4, correct? Yeah.
Yes.
So, I by 4 will be divided in 3 parts. So, this will see I by 12, this will see I by 12, and this will see I by 12, correct?
Yes, sir.
Therefore, we wrote I by 12. That is what I have written over here, I by 12. Because I am following this path. For me, is important what flows in this and what in this. So, this gets you I by 12. Here I by 12, here I by 4, when V infinity minus Vc is being taken, correct? So V infinity, infinity input, and C output gets us VAC as I by 12 into R plus I by 4 into R, correct here? I by 12 into R plus I by 4 into R. Same, exactly the same. We are following the same algorithm. And then we say, okay, let's take the other way around. And what is that? A is input, infinity is output, and then again calculate VAC. Okay. So A input, what flows this way? I by 4. And what will happen from here? I by 4 will divide in 3 parts. So up is what is of my interest. So up goes I by 12, correct? This way goes I by 4, correct or not, Sonit?
So it'll be the same thing.
Yeah. It will be not exactly the same because in the previous case it was I by 12, now it is I by 4.
No, I mean, like equation will come same.
Of course, that's the reason we have multiplied by 2 now. It's the same.
Okay.
So what do we get it as? VAC, VA minus VC will be equal to how much? I by 4 into R plus I by 12 into R. And then when you will add, you'll get VA minus VC. Find here, which will be this. VA minus VC will be this. How much, Krish? You said something about it?
Sir, I guess it's 2R by 3R equivalent.
Okay. So this is what we are getting for resistance across A and C. And A and B, of course, we know that is what the question is in IRDO. What will be against A and B? Okay. Now, few more questions we are to take on resistance. And we are also to see discharging of a capacitor. How does a capacitor discharge? So is this part clear? Shall we go for discharging of capacitor today itself, or you are saturated for the day?
I think
Your call.
saturated.
Oh, okay, fine, no issue. Okay, fine. Then we are keeping to
No,
this.
let
So I have this question on capacitors.
Please do ask. Tell me.
I'm sharing the screen now.
Sure.
So this one.
Okay. This question is an old question, very old question.
Did you
And
make
is
that?
there one of the institute? Is there in a package of one of the institute? Now, what is being given over here is one of the plate is at an angle theta, and then you are to calculate what is potential difference. This is from 15 years back, FITZI package. What will be they have asked capacitance. Okay,
Yes,
so you have to calculate basically what will be capacitance. Correct? Yeah, and dimension of plates being given to you. Correct? This is D. This part is D. Right, Aditya? This part is D. Right, Aditya?
Yes, sir.
Aditya, are you there?
Yes, that is D.
Wait a minute. I'll get you the original question. This is the question original. Can you see? Visible?
No, sir.
So can I stop the screen share?
Sure. Is it visible to all of you?
Yes, it's better.
I'll take a thing.
Yeah.
Yeah, yes,
Visible?
sir. Yes, sir.
Okay. So this is being given to you and theta angle given to you and D is given to you, A is given to you. D, as Aditya was showing, is that D and A is the size. It's a square plate. Plate is square. Is it okay?
Mm.
Plate is
Yes.
square. Side length A. Find here.
Mm.
So that is being given to you and we have to find capacitance. Basically, we have to prove capacitance. There they have asked you to prove that capacitance will be equal to whatever they have. Clear? How shall we go about it? Anyone? Any idea? How shall we go about finding? I'm limiting it to capacitance. Find capacitance of this structure. That's it. How
So
shall we go?
it's not parallel plate capacitor.
It is not. It is not parallel plate. Because parallel plate means they should be parallel to each other, which is not the case. It is not a parallel plate capacitor. D is given to you and A is given to you.
In the result, if you put theta equals to 0, then we'll get our parallel plate answer.
Then we should get the equation for parallel plate capacitor. If you put theta equal to 0, of course, we should get the equation of parallel. And that is what they are saying. See what we have to prove. You have to prove this, correct? Are you getting it? Are you able to see it? A square. Are you able to?
Epsilon
Yes.
naught
Put theta
square.
equal to 0 here. If you put theta equal to 0, what do you get? You get A epsilon naught by D, correct?
Is that
Yes,
a
sir.
to the power 1?
A square.
A square is square.
Wait, then we'll get
Not
a
visible.
square epsilon naught by d.
Yeah, that is epsilon naught A square by D and 1 minus A theta by 2D. So 1 minus A theta by 2D is the bracket. If you put theta equal to 0 over here, you'll get A square epsilon naught by D and A is the side length. So A square
Okay.
being a square, A square is the area. So we get it as A epsilon naught by D. Of course, we'll be getting it that way. So we have to prove that this is what we are getting when we find capacitance. How will we prove the capacitance to be this? Anyone having any inkling, any lead? How will you prove capacitance? How will you get capacitance? Anyone, any lead? Appreciate it.
On integrating, like taking each part.
Of course. So what
RD
you
is
have to do?
changing. Distance
Yeah,
changing.
exactly. You have
Yeah.
to take a very small stripe. You'll have to take a very small stripe. Once you take a very small stripe, you get to see two capacitors. Can we say that? Which two capacitors? We are getting this stripe, right? Now this stripe, this is D, okay. But what will be this one? The length between the plates, this length and this length, correct?
Yeah.
So we are ignoring on the slant. Are you getting it there? Can
Yes,
we
sir.
ignore on the slant? If we have taken it very small, can we ignore? Have we not ignored in this case? Do you remember? You remember
Yeah.
SC1 question in IT? What we did? We ignored this part, right? Yeah. This was also slant, correct?
Yes, sir.
Have you
Yeah.
solved this question or not? Your radio
Yes.
silence is speaking of you have not solved this question. I have given you, I presume, this question, right?
In class, yes, sir.
Class, yeah.
So we have not taken this part. We have assumed it to be straight, horizontal. Same over here. I'm assuming to be horizontal. That depends on how small is dx, and dx is very small. You know that well. Then what do we get? The distance between the plates. Now this part, and this part, they form a capacitor separated by d plus x tan theta. Can we say that?
Yes, sir.
Y tan theta will be y by x. Correct here? So what will be y here? Y will be x tan theta. Find here.
Yes, sir.
So y being marked as x tan theta. Therefore, separation is how much to us? D plus x tan theta. This is the separation. Okay, good enough. Now can we write for what will be small capacitance? Yes, small
DC equals
capacitance, small area. Correct, yeah? Small area. Small area will be dx into A. Agreed, Aditya?
Yes, sir.
Strip.
Yeah.
Strip. Are
Yeah,
you
yeah.
getting it, Aditya? Strip. It is
Yes.
inside, correct?
Yeah.
So dx is one length and A, as you know, is the side length, correct?
Yes, sir.
So area will be dx into A. A you got epsilon naught, of course, by D, correct? And D is x tan theta. Find here.
Yes, sir. Yeah.
Now you know what to do. Tan theta, of course, is constant, correct? Theta is constant,
Yeah.
correct?
Theta. Yes.
So you have to go for integration. Find here.
Yes. Yes, sir.
Will be able to further.
Yes, sir. Yeah.
So what is the integral of a plus bx?
A plus
1 by a plus bx, right? This is of that form.
1 by A plus B. You have to first take this as dx here. This is z. You have to change it. You assume this
Okay, we
as
have
z.
to go along. Okay.
You assume the denominator as z, another variable. Fine. Tan theta is constant.
Hmm.
Okay.
Yes, sir.
Yes, sir.
Okay then. Fine then. Let us conclude. Thank you,
Okay.
class.
And so
Thank
x
you,
will
sir.
vary from 0 to a.
Thank you,
X
sir.
will vary from 0 to A. Right. 0 to A. Correct.
Okay, sir.
Fine, Sanit.
Yes, sir.
Sometimes they do it by expansion of tan as well. So you check which one will be easier. I think, let's see what we are getting. Z is what to us? Z is equal to D plus X tan theta, right?
Hmm.
Try to I find DC. DC is what to us? 0 plus dx tan theta, correct? Tan theta being constant. So dx tan theta. I write it over here. It will be A epsilon naught, and then dx will be replaced by dz by tan theta. So dx will be replaced by dz by tan theta, and then divided by what term we have? Divided by we have z, correct? D plus x tan theta is z. So divide by z. So what do we get? We get A epsilon naught by tan theta ln of z, right here? When integrated, and z will vary from
Hmm.
where to where? Z will vary from d, because x is equal to 0, so z is equal to d. So d to d plus a tan theta.
Two A.
D
A
plus
plus.
A tan theta. Is it okay? So what do we get to see is A epsilon naught by tan theta and ln of D plus A tan theta divided by D. This is what we are getting. So that will get us A epsilon naught by tan theta ln of bracket open 1 plus A tan theta by D. 1 plus A tan theta by D. Of course, this is not the form that they have expressed in. Why so? Because you will expand now. and you will neglect the higher orders. Are you getting it?
Yes, sir.
1 plus x form, right here.
Yeah.
Form. This is the 1 plus x form. Can we take it that way? Check once. Tan theta is constant. What is A? A is large, right?
So we'll
So we
use
are
the
getting,
series expansion.
but then series expansion, higher order, I'll be able to neglect only when x is small, right? Here x is large, na? A tan theta by D will be large, correct? A tan theta by D. What is ln of 1 plus x we write, and then we can ignore the higher orders only when x is small, correct here?
Yeah, yes, sir.
And that should be given also.
Yeah.
Here it's not given to you. A tan, here it's not, logically it is not small, because D will be smaller than A and tan theta. So what we were to prove? We were to prove uh, epsilon naught, naught tan theta. Is theta small? Theta is small given. Theta is small given. If theta is small, show for small theta.
Okay.
Okay.
Yeah.
So for small theta, what will you get? Check once. A epsilon naught by theta, tan theta theta, and ln of. Now we expand. Theta is small. Theta is small. Allowed. So what will be? What will it be? Tell me. Function of this.
X
Yes, like
minus x squared by 2.
1 plus
1 plus a tan theta by d.
A tan theta by d. So A tan theta means theta by d. And then minus, you won't get.
And then we'll open ln 1 plus x.
That is what I'm saying. ln 1 plus x, when you open, what will you be getting?
X minus x squared by 2, right? ln 1 plus x. And
X minus x square by 2. So x minus x square by 2. So this will be squared then by 2. We're not getting this form. Why come? How? We are
no,
not
sir,
getting.
it'll come. Then we'll take a square common outside. If you open ln 1 plus a,
ln from where? From here. Here.
from the top one.
This one. What will you do?
We'll open it as x minus x squared by 2, where x is a theta by d.
So what will be 1 minus x square by 2, na? Neglecting the higher order?
Sir, it's x minus x squared by 2.
Right. So A epsilon naught by theta, x minus x square by 2. X will be A theta by 2.
Yes, sir.
And plus
A theta by d.
A theta square by 2d, correct? But we are getting plus
minus.
there.
Sir, x minus x squared by 2.
Minus,
And
correct?
They took a theta common.
And then we got. Then we got, right. Theta will be now, theta cancelled, and then we get this. Find here. Check.
Yes, sir.
Yes, sir.
That is what we were to do. We had to expand it to prove data. Fine. Okay, fine then. That's it for the day. Thank you, class.
Thank you,
Thank
sir.
you, sir.